Hello everyone, this is the answering session on exam 4 review questions. Exam 4 covers chapter 12. Okay, let's look at the review questions. First, some true-false questions. Okay. First one, the correlation coefficient R measures the strength of the linear relationship between the two variables. That is true, because that's exactly what R does, right? That's from the definition. Okay. 2. Pearson's correlation coefficient R requires that both variables be interval or ratio data. That is also true. Because R is also called correlation coefficient, is also called Pearson's correlation coefficient, and that's you have to have interval or ratio type of data in order to calculate that. If you're not very clear about what is interval, what is the ratio type of data, you should go back to previous chapters. We covered that before. Okay. Number 3. And by the approximate two-tailed test for correlation R.05, if R is 0.55 and N is 16, we would have significant correlation between X and Y. Right? And it is true. Why it is true? Because you need to calculate T equals R times, sorry, I have to use this, I can't put it in the symbol here, the square root of the whole thing here. The square, inside the square root sign, you have n minus 2 over 1 minus r squared, right? R times r squared. And what you have is 2.46. And the T critical at alpha 0.05 is, or is two-tailed test, so it's T 0.025 is 2.145. Since your calculated T is 2.46, which is larger than 2.145, therefore we have a significant correlation between X and Y. Or alternatively, you can also use the quick method. That is the R. See, if it's R, the absolute value of R is larger than 2 over the square root of n. 2 over the square root of n. N in this case is 16, so that's 16 square root is 4. 2 over 4 is 0.5. I know R is 0.55, which is larger than 0.5. Therefore, we can say it's significant correlation. Okay, so you can do this two ways. Number 4. A sample correlation R 0.4 indicates a stronger linear relationship than R equals to minus 0.6. Sorry. So this is false. Why is it false? Because when we look at the strength of a linear relationship, which one is stronger, right? We look at absolute value. Which one of them is closer to 1 or minus 1? In this case, the absolute value of R minus 0.6 is actually closer to minus 1 than this one to 0.1. Therefore, this is actually a stronger relationship. Therefore, this statement is false. Number 5. In bivariate data analysis, a common source of spurious correlation is when variation in both X and Y is actually caused by a third variable, Z. That is true. A third variable is causing, X, Y to change, to vary. Therefore, this correlation is spurious. So this is a true statement. Number 6. Correlation coefficient R always has the same sign as B1 in this equation. B1 is the slope. That's also true. The B1 is a positive correlation. B1 is negative, it's negative correlation and has a negative R. Number 7. To find the fitted intercept in the regression has little meaning if no data value near x0 have been observed. That is also true. Therefore, we don't normally look at intercept. We are more interested in the slope. Okay. Number 8. The least squared regression line is obtained when the sum of the squared residue is minimized. Is this true? That's the definition. And also it's minimized to 0, actually. Right? It's minimized, sorry, it's minimized. And the sum is 0. That's actually in this question, number 9. In least squares regression, the residues will always have a 0 mean. That is true also. Okay. Number 10. In the model, sales equals 268 plus 3.73 ads. An additional $1 spent on ads will increase sales by 7.37%. This is actually false. Why? Because this is ad spending, ADS here. If you increase this by 1, and the sales will increase by this much, by the slope, $7.37, but it's not percent. Since it says percent, it's not true. It increased by $7.37, not percent. Okay. If R squared, capital R squared equals 0.3941 in this model, then ads explain 39.41% of variation in sales. That is true. That is what R squared means. Okay. The ordinary least square regression line always passes through the point x bar, y bar. That's the mean of x and y. That is also true. In the simple regression, the correlation coefficient R is the square root of R squared, capital R squared. That's true also. Okay. Number 14. If SSR is 1800 and SSE is 200, then R squared is 0.9. That is true because R squared, this equals 1 minus SSE over SST, and SSE is given is 200. SST we know is the sum of SSR and SSE, 1800 plus 200. So 200 over 1800 plus 800 carry out is 0.9. Okay. Number 15. Cause and effect direction between x and y may be determined in most cases by running the regression twice and seeing whether y is that, equals that, and x equals that has a larger x R squared. This is simply not true. Okay? It's a false statement. You cannot establish cause and effect relationship by doing that. Okay? Number 16. In a simple bivariate regression, the F statistic is calculated by taking the ratio of MSR to MSE. That's true. That's how F test statistic is calculated. Number 17. The coefficient of determination is the percentage of total variation in the response variable y that is explained by product, the predictor x, that is R squared, capital R squared. That's true. Number 18. In correlation analysis, x, y are assumed to covary, but neither is designated as the independent variable. That is also true. Because, we only care about the relationship or how the two correlate. We're not, we're not concerned with which one is independent, which one is dependent variable. Number 19. There are usually several possible regression lines that will minimize the sum of squared errors. That's not true, because if you minimize sum of square line errors, there's only one line. That's our regression line. Number 20. When the errors in the regression model are not independent, the regression model is said to have autocorrelation. That's the definition of correlation. That's true. Number 21. Regression analysis deals with the structure of the relationship between x and y, while correlation analysis primarily measures the strength of the relationship. That is true. Okay. Let's look at some multiple choice questions. Go on. 22. The variable used to predict another variable is called the independent variable. Right? And the variable used to predict another variable, which the other one, another variable that is dependent variable. So the one that's used to predict is a predictor variable or independent variable. So C is correct answer. Okay. Number 23. A trucking company fitted a regression to relate the travel time in days of its shipments as a function of distance traveled in miles. The fifth regression line is time equals minus 7.1264 plus 0.0214 times distance, based on sample of 20 shipments. The estimated standard error of the slope is 0.0053. Find the t, calculate the t to test for zero slope. Right? The calculated t, by definition, is b1 minus 0 over the SB1. Okay, we know b1 is 0.0214 right here. So b1, and the minus 0, of course, is still 0.0214 over the standard error here. In this case, is standard error is 0.0053. 0.0214 over 0.0053 will give you 4.0377, or rounded up to 4.04. So therefore, C is the correct answer. Question number 24. If the attendance at a baseball game is to be predicted by the equation attendance equals 16,500 minus 75 times temperature, what will be the predicted attendance if temperature is 90 degrees? It looks like this is minus 75, the slope, meaning if temperature increases, attendance goes down. If temperature decreases, attendance goes up, right? So how would you calculate this? You basically plug in the 90 degree, in temperature. So the attendance equals 65,500 minus 75 times 90 degree. This will give you 97.59. Okay? And this is the closest one. Okay. Number 25. A hypothesis test is conducted at 5% level of significance to test whether the population correlation is 0. Right? If sample consists of 25 observations and the correlation coefficient is 0.6, then the computed test statistic would be what? The calculated test statistics equals R times the square root of the whole thing here, which is n minus 2 over 1 minus r squared. I use r times r for r squared. We have everything. We have r 0.6, and n is the n minus 2 is 25 minus 2, that's 23. 1 minus 3.6, that's the r squared. R is the 0.6, so therefore r squared is 0.36. You carry out the calculation, you should get 3.5968, or round it up to 3.597. C is the answer. Okay. Number 26. A researcher's results are shown below using FAMLab, labor force participation rate among females, to try to predict cancer. That's death rate per 100,000 population due to cancer in the 50 U.S. states. This is a regression statistics. Multiple r squared is just the r standard error, and observations 50 people. And this is the results, right? Of the regression results. This is the coefficient, standard error, and t statistics. Which statement regarding the relationship between FAMLab and cancer is valid? Okay. A rise in female labor participation rate will cause the cancer rate to decrease within the state. Why is this wrong? You cannot say this within the state, okay? Even though there's a negative relationship, but you cannot use this is actually shows the U.S. overall, the United States. You cannot apply that just to within the state. Okay? This model explains about 10% of variation in the state cancer rate. This is actually correct statement. Which one shows the percent of variation? Explain the variation. That's the r squared right here. R squared in this case is 0.09823, blah blah blah, and or 9.8%. So that's roughly 10%. So B is correct answer. Right? at 0.05 level, 0.05 level of significance, there isn't enough evidence to say the two variables are related, right? And we do not have that test statistic here, so we cannot say. And D, if your sister starts working, the cancer rate in your state will decline. Again, you cannot apply the generalized statistics to individual. So B is correct answer. 27. A news network stated that a study had found a positive correlation between the hair color of a worker and his or her salary. You may conclude that what? Of course, if blondes have better jobs, you cannot conclude that because that's spurious. Correlation should be negative, and causation is in series doubt. This is the correct answer because we don't have no reason to believe that the color of hair affects your salary. So everyone would dye the hair to whatever earns them the highest salary. Okay? So that's what this says. 27. 28. Mary used a sample of 68 U.S. cities to estimate the relationship between crime, that's annual property crimes per 100,000 persons, and income, the median income per capita in dollars. Her estimated regression equation is this: crime equals 428 plus 0.05 times income. If income decreased by 1,000, we would expect the crime will do what? Let's look at the equation here. If income decreases by 1,000, right, and that is income is times minus 1,000 times 0.05, that give you minus 50. That's what this term is going to be. So crime, since it's minus 50, the crime would decrease by 50. Therefore, B is correct answer. Okay. The rest, of course, are wrong. This is number 28. 29. Using the quick rule for significant correlation in a two-tailed test of R alpha 0.05 and N 400, we will look in the correlation matrix for any R whose absolute value exceeds what? The quick rule tells you 2 over square root of N. N in this case is 400. Square root of N is 20. 2 over 20 is 0.1. Okay, this is what we're looking at. Therefore, A is correct answer. Number 30. In a simple regression, which would suggest a relationship between X and Y? A large p-value, we know it's not, and we prefer a smaller p-value. A large t-test statistic, that's the answer, yes. Large p-value for F, no. Either large p or large t, that's not true. So there's B is correct answer, only B. Number 31. Simple regression analysis means that what? The data are presented in a simple and clear way. That's not true, simply, right? There are only a few observations, so the calculations are simple. That's not true. In fact, when we use a computer to calculate, it doesn't really matter how many observations, a dozen or 100 or 1,000, it probably take about the same time. There are no more than 2 independent variables. That's not true. You can have more than 2. We have only 1 explanatory variable. That is true. Yeah, that's a dependent variable. Okay. 32. If the fitted regression is this, R squared 0.25 and then 25, it's incorrect to conclude that what? Y increases 2.1% for a 1% increase in Y. That's not true. If X increases by like a 2.1, right, Y will increase by 1. If X increases by 1, then 1 times 2.1 is 2.1. So the Y will increase by 2.1, but it's not a percent, right? So this is incorrect because of percentage. So incorrect. Therefore, that's correct answer. Okay. Number 33. When homostaticity exists, we expect that the plot of the residuals versus the fitted Y will show no pattern at all. That's from the textbook. And actually, this is not required of you. So so you don't need to worry about it. This is for your knowledge. Okay. Number 34. Which is correct to find the value of the coefficient of determination R squared? Definition: SSR over SST. Okay. The next question, last question, I believe. It is the last question. Consider the following line linear trend equation of an industry's sales. Y equals 120 plus 12 times T, where T is measured in years and sales are measured in millions of dollars. Which is the most reasonable conclusion? A, we would forecast that sales will increase by $12 million in next year. Yeah, this is the correct answer. Why? Next year, meaning one more year, right? So T is 1. If T is 1, T 1 times 12 gives you 12. That increase in YT, in the Y. So the sales is indeed going to increase by 12 million. That is correct. We will forecast the sales will increase at 12%. Again, we look at the previous example. We know the not percentage, right? This is wrong. On average, sales will increase 12 times 0.05 or 5% next year. Yeah, that is not true because 12 times T, where is 10 from? That's not true. The year-to-year average change will depend on the value of T. The year-to-year average change is not just that. It depends on the year-to-year average change will depend on the year-to-year average change will depend on value of T. That's not true because it's T is measured in years. From year 2 to year 1 to year 2, or from year 5 to year 6, they're all the same. The change is all going to be the same. It's not so it's not has nothing to do with the value of T, but only with the increase in T. It has nothing to do with the value itself. So A is the correct answer. I believe that's all we have for this review. So that concludes the answering review session for exam 4 review questions covering chapter 12. And I wish you good luck on your test.